In last video, we discussed about the mathematical expression for first law of thermodynamics, and according to first law of thermodynamics, delta U is equal to W plus Q, where delta U is change in internal energy, W is work done. If it is minus W, then work done by the system on the surrounding. If it is plus W, then work done on the system by the surroundings, and Q plus Q, it is heat supplied to the system. Now next point is first law of thermodynamics for various processes. Now first of all, you consider the isothermal process. For isothermal process, temperature remains constant, that is delta T, it is equal to 0, and internal energy depends upon temperature. As long as temperature remains constant, internal energy of the system also remains constant. So when delta T is equal to 0, then delta U must be equal to 0. But the first law of thermodynamics is delta U is equal to Q plus W. And as for isothermal process, delta U is equal to 0, then we get 0 is equal to Q plus W, or Q is equal to minus W. Now this implies that for isothermal process, heat supplied to the system is utilized to do work. Heat supplied to the system, it is utilized to do work, or whatever heat is supplied to the system, that work is utilized by the system to do work. Okay, minus W, it is work done by the system on the surroundings. Now consider the adiabatic process. And adiabatic process is a process in which neither heat enter into the system or goes out of the system. That is, for adiabatic system or adiabatic process, Q is equal to 0. Q is equal to 0. So this is the mathematical expression for first law of thermodynamics. Delta U is equal to Q plus W. But for adiabatic process, this Q, it is 0, and therefore delta U is equal to 0 plus W, or delta U is equal to W. It means for adiabatic process, change in internal energy, it is due to work done on the system by the surrounding. Work done on the system by the surrounding. Now this equation, that is delta U is equal to W, we can write in another way also. Just when we reverse the signs, then we get minus delta U, this is equal to minus W. It means work done by the system at the expense of internal energy. Work done by the system is at the expense of internal energy. Now consider the isochoric process. For isochoric process, volume remains constant. So delta V, it is equal to 0. This is the first law of thermodynamics. Delta V is equal to Q plus W. But you know that W is equal to minus P delta V, and therefore this first mathematical expression for first law, it can be also be written as delta U is equal to Q minus P delta V. But here delta V is equal to 0, and therefore this P delta V term, it will be 0 for isochoric process, and therefore we get delta U is equal to QV. Meaning of this is heat supplied to the system at constant volume, it is utilized to change in internal energy, or at a constant volume there is no possibility of any work. In this final relation, there is no any term related to the work. So for isochoric process, there is no any work, and in isochoric process, increase in internal energy is equal to the heat absorbed by the system at constant volume. Now consider the isobaric process. For isobaric process, pressure remains constant and therefore delta P is equal to 0. And the first law of thermodynamics is delta U is equal to Q plus W. By rearranging terms, we can write delta or at constant pressure. Actually, here there is no any delta P term. Delta P term is not there. So the same equation we can write here, delta U is equal to QP plus W, where delta U is change in internal energy, QP it is heat supplied to the system at constant pressure, plus W is work done. So this is for isobaric process. Now again you know that W is equal to minus P delta V, and therefore the same equation we can write in another way, delta U is equal to QP minus P delta V. So this is about the first law of thermodynamics for various processes, that is isothermal process, adiabatic process, isochoric process and isobaric process. Now next important point or thermodynamic term, that is the enthalpy. Its symbol is capital H. Now enthalpy, it is the sum of internal energy and pressure volume type of work at a constant pressure, and therefore mathematically we can write H is equal to U plus PV. Enthalpy, it is a sum of internal energy and pressure volume type of work. So H is equal to U plus PV, where U it is internal energy, H is enthalpy, P is pressure and V is volume. You know that pressure, volume and internal energy, these are the state functions, and therefore enthalpy is also a state function. It depends upon initial and final state. Now consider the system changes from initial state to final state, or there is a chemical reaction where reactants are converted into products. Now for this change of system from initial to final state, consider H1, it is the enthalpy of the initial state or for the reactants, and H2 it is the enthalpy of final state or products. Then we can write H1 is equal to U1 plus P1 V1, this is for initial state, and H2 is equal to U2 plus P2 V2, this is for final state or for the products. Now subtracting this equation 1 from equation 2, we write H2 minus H1, this is equal to U2 minus U1 plus P2 V2 minus P1 V1. But H2 minus H1, this is the change in enthalpy, that is delta H, and U2 minus U1, this is the change in internal energy, that is delta U, and therefore the equation we can write delta H is equal to delta U plus P into V2 minus V1. Now at a constant pressure, the initial and final pressure will be same, that is P1 it is equal to P2, that is equal to P, and therefore delta H is equal to delta U plus P into V2 minus V1. This P1 and P2, if they are same, then this becomes a common term, and therefore we get delta H is equal to delta U plus P into V2 minus V1. Now V2 minus V1, this is a change in volume, that is delta V, and therefore final equation is delta H is equal to delta U plus P delta V. So this is the mathematical expression for enthalpy. Now the relation between enthalpy change and internal energy change for solid, liquid and gas phase reactions. So first of all, consider the solids and liquids. For solids and liquids, there is no any change in volume when reactants are converted into products. When gaseous reactant, when solid reactant is converted into solid product, appreciable change in volume is not there. So for solids and liquids, change in volume is negligible and it is nearly equal to 0. Now the mathematical expression for enthalpy change, it is delta H is equal to delta U plus P delta V. For solids and liquids, this delta V term is 0 and therefore this entire term, that is P delta V, it will be 0. So for solids and liquids, delta H is equal to delta U plus 0 or delta H is equal to delta U. For gases, we can apply the ideal gas equation, that is PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is gas constant and T is a temperature. Then for gas phase reaction, when reactants are converted into products, then for reactants at a constant pressure and temperature, we can write PV1, it is equal to N1 RT. This is for reactants. Actually V1, it is the volume of reactants, N1 number of moles of reactants, P is a pressure, R is gas constant, T is a temperature. These three terms are constant because we are keeping pressure and temperature constant and gas constant R is also constant. Similarly for products, PV2, it is equal to N2 RT. This is for the products. Again V2 is a final volume or volume of products and N2 is number of moles of products. Now subtracting equation 1 from equation 2, we get PV2 minus PV1 plus N2 RT minus N1 RT. Now PV2 minus PV1, this is P delta V. This is equal to N2 minus N1 into RT. So N2 minus N1, what is N2? N2 is a number of moles of gaseous products and N1 is number of moles of gaseous reactants, and R and T, these are the common terms, and therefore N2 minus N1, this is the delta N. So we can write P delta V, it is equal to delta N RT. So this G stands for gas. So delta N, number of moles of gaseous products and gaseous reactants, difference between number of moles of gaseous products and gaseous reactants for this is the delta N. Now as P delta V is equal to delta nRT, this equation, that is delta H is equal to delta U plus P delta V, this equation becomes delta H is equal to delta U plus delta nRT. So this is for the gases. Delta H is equal to delta U plus delta nRT. So again delta H, what is delta H? It is change in enthalpy. Delta U means change in internal energy. Delta N, this term is very important. It is the difference between number of moles of gaseous products and gaseous reactants. R is universal gas constant and T is a temperature.